Hello, everyone. All right, so we're going to get started here. Before we do you have any questions for me? All right, so just initially, I sent that email out today, so hopefully everybody had a chance to read it regarding the midterm next week. So it's available in an online class. You have the whole week that you can take it. You just have to take it no later than the end date, which would be the following Sunday. So it's available from Monday of week 6 through Sunday, which is the last day of week 6. Now, this, of course, is dependent upon the availability of your proctor. So it's from 18th through the 24th of June. And so I'd like to think I don't have to state the obvious, but if your proctor's not open on Sunday, you can't take your midterm on Sunday, and that doesn't mean you get an extension until Monday. It means find a different day to take your exam, all right? So anytime next week, dependent upon the availability of your proctor. And yes, if you complete even if you would complete portions of the midterm, like maybe you choose not to do, chapter 1 because you're thinking I got that and you wanted to focus primarily on the areas that are maybe challenging you a little bit more, you can certainly send me the midterm review and I'll review it. You just want to make sure that you get it to me a couple days prior to when you plan on taking the exam, so that way I ensure that I actually see it and I get it back to you, and because it takes a little bit of time to review it all. Okay, and to give you, good feedback. So you just want to make sure if you're going to complete the midterm review for me to take a look at. I mean, certainly I would strongly recommend everyone to complete the midterm review. It's an excellent way to prepare for the midterm, and especially if you've already scheduled a tutoring session for this week or next week, you can take that review sheet with you and have, gone through it. You can go through it with your tutor or have them help you with the challenging parts. But I'm more than willing to look at it as well. I just want to, give me a couple days before you plan on taking it to make sure that I can actually provide you with good feedback. All right. As I stated in my email today, the exam is going to contain some true, false, some multiple choice, and then short answer. And those short answers could be a definition, like what is the definition of encapsulation? Or the short answers could be coding segments where we ask you to write a constructor with a specific name that initializes instance variables to specific values or something along those lines. Or we ask you to call a constructor to create an object, something along those lines. The exams for programming classes in general are quite challenging. So they are not one that you just want to go in and say, whatever, I'm good. You really want to spend the time preparing for these exams in order to score the best score that you possibly can on them. And I teach, 111, 101 and 111. The exams are equally challenging for both classes. So if you've taken 101 before and you remember your shock at encountering that first midterm, yes, it's the same. You can expect the same sort of situation here. Okay, so they're hard. All right, so you want to make sure that you're properly prepared. I do not curve, so there will be no curve. Your grade will be what your grade is when you take the exam. So just want to make sure everybody's aware of that. And likewise, there's no extensions on exams. It's to be taken the week, next week, and that's it. The only time that an alternative is provided is if you come to me like now and say, oh my gosh, I am being sent on training exercises next week, what can I do? then we'll make some arrangements on that regard. But yeah, it has to be made prior to the midterm, not after the fact that you come to me and ask me for an extension. So any other questions about the midterm? No notes, no book. The only thing you're allowed is scrap paper. Even if you're taking the exam on ProctorU, they lock down, so you're no Google, no internet, even though you're on a computer. ProctorU will lock down your computer. You have to have a webcam to use ProctorU, and they have somebody physically sitting there watching you through your webcam as you take your exam. So they lock your computer down to the test application only, and then somebody is sitting there physically watching you take your exam. So yeah. Well, I mean, I guess somebody at the testing center is also watching you. They're just, you can actually see them out there versus in ProctorU, it's kind of this unknown person watching you. So anyway, those are the restrictions on the exam. So you really want to make sure that you're well prepared. And then likewise, as I put in my email, if you're like, dang, I can't remember, you want to grab a string out of the middle, but you can't remember that it's specifically the substring, that's the specific name of the method, then, just put out in English what you would do, or just write it out as best you can. I can't give you 100% credit, but I can at least give you some credit if I can tell by what you've provided that you understand the question and you have a good feel for what needs going on, and I can, and it'll be obvious to me, all right, they just forgot the syntax of whatever, but they know what's going on here, then I can at least give you partial credit on an assignment, on a question. But if you leave a question blank, then the only thing I can give you is a 0 for that particular question. All right. Any other questions or anything else you want to know with regards to the midterm? All right, well, we're going to go ahead and get started. And these things, well, if they're in the midterm review, then it's possible. I can't remember. I think this week 5 stuff is also fair game for the midterm as well. Okay. All right, decision structures, comparison operators, and or knots and truth tables. So now we're going to start to get into some of the good stuff at programming that gives us flexibility with what we're doing. All right, so decision structures. These are something really that you guys do all the time, day in, day out, from the moment you wake up till the moment you go to bed, you are making decisions, right? So with a decision structure, what it does is it checks a condition. And if that condition is true, then one action is taken. And if the condition is false, then you may or may not take an alternative action. It depends upon what you need to do. So you think from the minute you wake up, you have the option, do I hit the snooze or do I not hit the snooze, right? And if you hit the snooze, then you get to sleep an additional 10 minutes, right? Otherwise, you get up and you're on time to work, kind of a thing. So decisions are happening all day long. So these decision structures are more commonly known as if-then-else, if-then statements or if-then-else statements in programming languages. They keep changing all the terms, but if you're familiar with the concept of if-then or if-then-else, that's what a decision structure is. So you're just making a decision and taking an action based upon that decision. All right, so we have single alternative decision structures, which is basically just an if-then. We're only going to take an action if a condition is true. And so the format for that is if, and then we have an open and closing parentheses, and inside the parentheses we're going to put our condition. Then we're going to have open and closing curly brackets, and the statements that we want to execute if this condition equates to true are going to be inside of these opening and closing curly brackets. Now there's one exception. If you only have a one-line statement, if there's only one statement that's going to execute if the condition is true, then you do not need the curly brackets. But I would like to suggest to you, especially as you're just getting used to the Java language, to just go ahead and put those curly brackets in there anyway, just as a good habit. It's a reinforcement to you that these are the statements that fall within my if condition. And so here's what an example would be. If And we've got our open and closing parentheses. The age is less than 4. Then we've got our open and closing curly brackets, system.out.println, still a toddler. Okay. If the score is greater than or equal to 90, so if this equates to true, the score is indeed greater than or equal to 90, then we'll print out you have earned an A. Okay. If this equates to false, then what happens is you jump down here below the if statement and you continue on with any statements down here. All right. The double or dual alternative decision structure, that's an if then else. It means you're going to take an action if it's true and you're going to take a different action if it's false. Okay, so the format is if condition in parentheses and then your curly brackets to define the statement you want to execute if it's true, else, and then the curly brackets to define the statement you're going to execute if it's false. Okay, and here's what that might look like. If my grade is greater than 70, print out you passed the course, else you did not pass the course. So if it's greater than 70, meaning it's 71 or higher, you pass the course. Otherwise, if it's equal to 70 or below, you did not pass the course. Okay? So I don't need to put another condition in here in the middle. If I hit this else condition, then I know my grade was not greater than 70. All right. So when we're doing comparisons in these conditions for our if then else statements, the comparison operators are kind of the same ones that we use in math. You have your greater than equal, less than, or less than equal. And I really want to stress it's greater than equal. It's never equal greater than. And it's less than equal. It's never equal less than. Okay, so you always start with either your greater than or your less than symbol. And then if you also want equality, you append on the equal sign onto the end of it. All right. Now, when we're checking for equality, on the other hand, we're going to use a double equal sign. The single equal sign is for assignment. We're setting one variable equal to another value. Okay. The double equal sign tests for equality. It tests to see if the two values or the two objects are exactly the same. Now, the not equals, so this exclamation point equal, that is a not equal. It's going to test if two values are not equal to each other. So sometimes it's to your benefit to test for equality, and sometimes it's to your benefit to test for not equal or not equality. It just depends upon what it is that your program's doing and what you need to check for. All right, so here's an example. If x equal y, we're going to print out x is equal to y. So we're testing for equality here. If x is not equal to y, we're going to print out x is not equal to y. Okay, so always if space, and then we have our open and closing parentheses. Inside the parentheses is your condition, and then the statements that will execute follow inside of a pair of curly brackets. All right, now, testing for equality with the double equal sign is only used with primitive data. You cannot use it when you're comparing two objects. Okay, so if we're comparing two integer values or two double values, character values, or Boolean values, we can use the double equal sign. But when you're comparing string objects, if you use the double equal sign, what you are looking for is you're looking specifically to see if those are the exact same object. Is string 1 the exact same object as string 2? So you're not looking to see, does string 1 contain the same values as string 2? What you're looking in memory and going, do they occupy the same location in memory? Meaning two different names pointing to the same object in memory. Okay, so kind of think of, so Matthew, I'll use you for an example, I imagine, or that someone has called you Matt through the years, right? So you're Matthew or you're Matt, but you're one person, just two names to get to the same person. And that's what you can have here is if string 1 and string 2 both point to the same location in memory, it's two names pointing to the exact same object. And that's the only time that this would equate to true. If these are two completely different objects, even if they contain the same value, So even if both of these strings contained like COMP-111 inside of them, that was their value, if they are not the same location in memory, they are not considered equal with this double equal sign. Yes, Owen, we'll get to that in just a minute. So I want to really stress this because this will catch you in Lab 3 without a doubt. All right. I'm going to have a lot of people send me their code saying, I don't understand why this isn't working, and this is going to be the exact reason why here. So when you're comparing string objects, what you have to use is there's a series of 3 methods that you can use to test for equality. So we have the dot equals method, and that checks to see if string 1 contains the exact same case and everything value as string 2. So the dot equals, it has to match exactly. Okay. There is, oh, and I didn't put it in here. There's also, oh, well, here's an example. So temp 1 contains COMP-111, temp 2 contains COMP-111, but these are 2 completely different objects. They each occupy their own location in memory. So if we use if temp 1 equal temp 2, it's going to be false because even though they contain the same value, they are different objects. They have different memory locations. But if I use temp 1 dot equals temp 2, the value will return true because they contain the same value. Even though they're different memory locations, they contain the same value, so they would come back true. All right, so here's the 3 different equality methods you have. You have the dot equals, and you pass the string you're comparing inside of the parentheses. Exactly, has to match exactly according even to the case level, okay? We have dot equals ignore case, and those, they have to be the same characters, just not the case, okay? And that should not be the word cannot, but should be contain. So they have to contain the same characters, but it's not case sensitive, okay? And then the compare to, this is used for sorting if you're sorting alphabetically. So it's going to give you 0 if they're exactly equal. It's going to give you a value less than 0 if the string you're passing in comes before the string that you're comparing it to. And it's going to give you a value greater than 0 if it comes after it. So you use the compare to when you're trying to sort things in an alphabetical sequence, which as programmers in our programs, we're always sorting things alphabetically, right? It's just a standard. If you're giving somebody a list or a drop down or whatever, it should be in alphabetical order. It's what our users expect. So this compare to comes in really handy. It compares not only the letter, it compares every letter. So it will you so much for waiting. My internet connection just dumped me, which was not fun. All right, let me get back to, so I was asking if you guys understood the difference between the two. Oh, well, that's weird. Yeah, it is weird that we both lost connection. Are you happen to be in the Dublin area, Dylan, or out by Plain City? Huh. I am going to have to say I'm a little bit less than impressed with Spectrum's digital service, but oh well, that's a whole nother story. All right, no, the dot equals cannot be used on integer values, and the reason why is integer values are primitive, right? So primitive data has no methods associated with them. They are strictly just data. So the dot equals method is actually something that would have to be written and be part of the class, the blueprint that is defined with your object in order for you to be able to call it and to be able to use it. So integer data is you're only going to use the double equal sign. If the dot equals method has been written, then you can use it with your object. So the string object or the string class has written a dot equals method to do comparison. But for like our golf, our player object that we created, we cannot use the dot equals because we did not write a dot equals. Now, if we write a dot equals method, then we can call it. Oh, okay, so if you're comparing them alphabetically, it's going to be based upon the ASCII characters, and I, off the top of my head, cannot remember. ASCII code set. So where are you at? Where's my capital A? Capital A is an ASCII 65, and a lowercase a is an ASCII 97. So uppercase will sort logically before lowercase. Did that answer your question, Dylan? Okay, great. So if you have two integers, you're just going to use the dot equal, or not, I'm sorry, not the dot. You're going to use the double equal sign, the equal equal, if you're checking for equality. Now, that doesn't work in the case of double values. I'm not sure if I have that in here. Okay, so I'm on slide 16. I don't think I'm doing that. So let me take a side break here and go into comparing double values. Okay, so the problem we have when you're comparing double values is that the computer is willing to go out forever, right, as far as decimal places go. But we as humans are not willing to go out forever, right? We have our limitations. We're only willing to go out so far. So what you do is you set a close enough kind of a value. So you would have, so let's say we have a double val 1, and that equals like 5.98345678, something like that. You know what I mean? And we have a double val 2, and that also equals 5.98345678 okay? If we were to just say if val 1 equals val 2, those are not going to be equal, okay? Even though, you know, maybe we've computed the number out this far, but the computer doesn't do any rounding and stuff, and so it computes out this far. To the computer, these are not equal. They're not the same number, even though we could care less. We're like, seriously? They're the same out to 7, you know, 8 decimal places. It's good enough for me. The computer is going to say they're not equal. And sometimes, even if they did look equal, the computer will still say they're not equal when you're comparing double values. When you're comparing integers, you can definitely use the equal. So what you do is you set some sort of, they call it an epsilon value, or you can think of it as a delta value, like in our assert equals test cases. So we would take a double epsilon, and we would set that equal to some value, like out to, this many decimal places. So if our two numbers are equal out to this point, then as far as I'm concerned, good enough. So in here, what we would have is we would have a math dot absolute value, val1 minus val2 is less than dot, or epsilon. Epsilon. I spelled it wrong up here. Okay. Oh, sorry, not equals, minus. All right, so what we do is we subtract the two values from each other. And because we don't really care which one is greater than the other, we just want to know what the difference is, we do an absolute value. Because it could be that value 1 is the higher number, in which case this would result in a positive, right? But it could be that val 2 is actually higher. And in this case, val 2 is the higher number because it's got additional things going on here. So if I were to do val 1 minus val 2, I end up with a negative number. So rather than having to worry about whether my result is negative or positive, we just we wrap it in an absolute value. So we call the math.absolute value to always convert it to a positive number. Okay, then we check, is this positive number less than our epsilon, which we've set to whatever precision we need in our equality. And if it's less than our epsilon, then as far as we're concerned, they're equal numbers. If it's greater than our epsilon, then we would say that they're not equal numbers. Okay, so when you're comparing integer values, so if we had an integer val1 equals 7 and an integer val2 equals 7, then we can just say if val1 equal val2, and that will appropriately test for equality. But in the case of double values, you have to do a little bit of extra work to be able to check for equality, just because computers are willing to take things out, forever, and humans, we are not. Okay, did everybody follow the difference here between comparing double values and comparing integer values? Okay, and likewise, if we had character values, you can definitely, oh, that's supposed to be an equal sign right there. Character values, you can definitely do equality with character values, or Boolean values, you can do equality with Boolean values as well. It's just the primitive data double values that you have to do this extra work. All right, back here, slide 16. All right. So if we wanted to actually test to see if two objects contain the same values, their instance variables contain all the same values, then we have to actually write a method to do that. Now in the string class, that's provided for us, so we don't have to do anything. We can just call the existing method. But for any objects that we create, if we needed to test for equality, we have to actually write those dot equals methods. This will get a little bit way out there, so if you want to just turn off your brains right now, you can just ignore this. You'll encounter it more in COMP-121, and it'll make a lot more sense in COMP-121. But the Java developers, they embraced object-oriented technology within the entire language. So what they do is they create this base level object, this base level class and object at the highest level, and then they expand on that and expand on that and expand on it till it gets to the point where we are writing our own classes and objects. Okay, so at that base, so essentially what we're doing when we're writing our own classes and objects is we're just redefining that very vanilla object that they created up at this top level. Okay, so all objects have a toString method and a dot equals method and a vanilla or default constructor. But the problem is that they didn't know in this vanilla object up here that has this vanilla dot equals and this vanilla dot toString and this vanilla constructor, they don't know what our stuff is going to look like, right? So even though a dot equals exists, it's not written specifically for our stuff. So you can call it, but it's not going to give you the result that you want. And so what we have to do in our classes and objects that we're creating is we have to redefine those methods to be specific to our classes and our objects. So that's why I don't want you to be like, oh, well, I can call the toString. Well, it's because it exists, but it's generic. It's not written specifically for our data. So if you really want something to work with your data, you have to redefine that object and write that method yourself. And that's what I'm going to show you how to do here. So we have our dog class Boolean. So let's say we're going to write this dot equals method. We're going to return a Boolean value of either true or false. True if all the instance variables are equal, false if the instance variables are not equal. Okay. So we're expecting a dog object to be passed into this as our explicit parameter. So it's called, our implicit parameter will be a dog object that calls it, and then our explicit parameter will be a second dog object that's passed in, and we're going to compare the instance variables from our implicit to our explicit. Now, if that isn't confusing, hold on, we'll go through here. So what we have to do is we have to compare each instance variable. So what this looks like is our implicit, remember, uses the keyword this. So the implicit is the one that's the method is being called on. So this dot name, this dot breed, and this dot age. And our explicit is the one that's passed in. So for our explicit, I have to call the method. So indog.getName to retrieve the name. And I compare that to this dot name of my implicit. And if those two are equal, then I'm like, okay, step one, these two are equal. Then I can come down here and I can check for equality in the breed. So I call the getBreed method on my explicit parameter and compare that using the dot equals to the breed of my implicit. And then the same with the age. Now the age is integer data, so I can just use the dot equals. And if this is equal and this is equal and this is equal, then I return a true. Otherwise, I just return false. Okay, so you don't have to worry about writing this code or having to do anything along these lines. I just kind of wanted to show you why you just can't assume that you can do this with any object, or that you could just say one object is equal to the other object. You have to be able to compare each instance variable to know for sure that they're equal. And that's really why I went through this example here. So Matthew, just let your brain go back to where you were before. It's okay. You don't have to know this. This is just really to kind of show you why the equality doesn't work, with the double equal sign. All right. We're going to move on. And, ors, and nots. So there's times when you want to combine conditions together. And so the and the or allow you to do that. With an and condition, it's looking, you can say if condition 1 and condition 2, if both of these are true, if condition 1 is true and condition 2 is true, then the whole thing is true, right? With an or, it's if condition 1 is true or condition 2 is true, then the whole thing is true. So in an and situation, when you and things together, both conditions have to be true for the whole thing to be true. And in an or condition, either condition, if either condition is true, then the whole thing is true. All right, so the and is represented by a double ampersand in Java. Both conditions have to be true, and they both have to be complete conditions, okay? So x is greater than y is one condition, and this can equate to either a true or false result. And x greater than z, this x greater than z is also a full condition that equates to either true or false. And then so what you would do is you would first figure this out, is this true or false? Then you figure this out, is this true or false? And then you and them together. And if both of them are true, the whole thing is true. And if either or both are false, then the whole thing is false. Okay. So each has to be a complete condition, so you can't go y is less than x is less than z. That's valid in algebra, but not valid in Java. You have to do y is less than x as one condition and x is less than z as a second condition. The OR is represented by a double pipe symbol, double pipe sign, and at least one condition must be true. So here we have x is greater than y or x is greater than z. So if either one of these is true, then the whole thing equates to true. All right. So one of the common things that you'll do with your AND or your OR symbol is you're going to check for a range. When you're checking for a value inside of a range, like is this number between 2 and 7, you're going to use the AND condition because it has to be greater than or equal to 2 and it has to be less than or equal to 7. So whenever you're checking for something inside of a range, you're always going to use your AND symbol, which is the double ampersand. If you're looking for a value outside of the range, you're going to use your OR symbol because it can be less than 2 or greater than 7, and then it would be outside of the range. And the OR symbol is represented by that double pipe. Okay, so I'm just going to run you through this example here as to why you want to use the AND versus the OR. So if we're assuming x has a value of 42, and we're going to check for it to see if it falls within the range of 10 and 20. So we would check to see, is x greater than or equal to 10? And yes, it is indeed greater than or equal to 10, right? So that part equates to true. But then we check to see, is x less than or equal to 20? And it's not, it's false. And so this would come back with a false. 42 is not inside the range because one of the equations equated to false, and they both have to be true. If we look for a value of 2, we would first check, is x greater than or equal to 10? And it's not. That gives us a false. And is x less than or equal to 20? Yes, it is. So that's true. We have a false true. And in an AND, both sides have to be true. So 2 is not in the range of 10 to 20. And then when we get to a value of 12, 12 is greater than or equal to 10. So the first half equates to true. 12 is less than or equal to 20, so the second half equates to true. Both are true, so this whole result would be true, and 12 is indeed inside of the range 10 to 20. Now I want you to notice what I've done here, right? Not only did I show you how the AND worked, but did you see I tested each side of my AND, right? I tested below the lower boundary, I tested above the upper boundary, and I tested right in the middle of my boundary as well. When you're writing code, this is the sort of, when you're testing your code to see, is it doing what you're expecting? Is it solving your problem? You want to make those same sort of tests. You want to test something on one side, below the lower, above the higher, and right in the middle to make sure that it's doing what you think it's going to do. So even on your homework problems, you want to go, all right, let me just run some numbers through this. Is this doing, if I have this number, is it doing what I'm thinking? If I have this number, is it doing what I'm thinking? And if I'm right here in the middle, is it doing what I'm thinking? Okay, so let's look at the OR symbol and try it trying to look for something inside of the range. Even though we know that's not going to work, let's see what ends up happening. So we say we're back with our value 42. 10, is x greater than or equal to 10? Yes, it is. Is it less than or equal to 20? No, it's not. But we have an OR symbol, so if either side is true, then the whole thing is true. So this is going to come out true even though 42 is not between 10 and 20. Because the reality is a number, like when I'm looking at this number is greater than 10 or less than 20, that encompasses all the numbers, right? It's a finite, because a number is, if it's greater than 10, it's 10 up to infinity, so it could fall in any of that range. And if it's less than 20, it's 20 down to negative infinity, so we've actually covered every single number possible to man in this range. All right, and so what we get is, okay, so that would be, let me go back there. So if we did 2, it's going to be, if 42, it's true. If it's 2, it's going to be true. If it's negative 14, it's true. If it's 147, it's true. If it's 20, or even if it's 15, it's true. No matter what number in an OR situation like this, we will always get true whether the number's inside the range or not. So that's why you go with the AND symbol. All right, looking for something outside of the range. So you're going to use the OR as the appropriate way to do something outside the range. So if we go with the value of 42, is 42 less than 10? No, it's not. Is 42 greater than 20? Yes, it is. So we have a false true. And in an OR, if either side is true, the whole thing is true. So yes, 42 is indeed outside the range. We go with a value of 2. Is 2 less than 10? Yes, it is. So that's true. Is 2 greater than 20? No, it's not. So we have true, false. But if either side is true, the whole thing is true. So 2 is indeed outside of the range. Okay, and then if we go with a value of 12, which is inside the range, is 12 less than 10? No, it's not. That's false. Is 12 greater than 20? No, it's not. That's also false. So we end up with a false, false. And so we would come back and say, no, 12 is not outside of the range. Now the last example is doing this outside of the range with an AND symbol and trying it with a value of 42. And so is 42 less than 10? No, it's not. That's false. Is 42 greater than 20? Yes, it is. That's true. We have an AND symbol, so false, true. It equates to false. So it will not tell us that it's outside of the range. And the reality is that no matter what number we put in here, it's always going to be false because a number cannot be both less than 10 and greater than 20 at the same time. So if you're trying to look for inside the range and you accidentally use the OR symbol, everything will be inside the range. So you're going to get false data because everything will show up inside the range. If you're trying to look for things outside the range and instead of using the OR you end up using the AND, you will never find a number outside the range outside the range because it will always equate to false with the AND because the number can't be both less than the lowest value and greater than the highest value at the same time. All right, did you guys follow that? Just kind of showing you how the ANDs and the ORs work. There is not an XOR, but there's, in the sense of an XOR, but there's a not symbol, so you can actually do the OR and then not it, which would accomplish the same sort of a thing. And here we go, not, perfect lead-in. Owen, thank you. So the not symbol is your exclamation sign, and it's going to reverse your result. Okay, so if it was originally a true value, it's going to equate it to false. And if it's originally a false, it's going to equate it to true. Okay. So we have x is not equal to y. So that would just say if these two values are not equal, then this would be true. We have a not, and then notice this is in parentheses, x equal y. So first we would check, is x equal to y? And if it is, then we reverse it. So if it's true, it becomes false. If it's false, it becomes true. But you cannot do this, not x equals y. Now the only time you can do this is if x and y both contain Boolean values. But if x contains a 7, you're like going, not 7. And how can 7 not be 7, right? 7 is 7. So you can't say not x. You want to either put it here, x, if your intent is to say x is not equal to y, you put it here, okay? Or you put it outside the parentheses and compare it out here. Did I answer your question, Owen? Oh, great. Which one doesn't make sense? Oh, the exclamation point, using the exclamation point for a not symbol. What symbol would be better on the keyboard? Because we don't have the equals with the slash through it, which is what we used in algebra, right? So there's no character that has the equals with the slash in it. Yeah, I suppose you could use a tilde, although a tilde typically represents approximation, right? So they just chose something, Matthew, and the exclamation point was what got chosen. Oh, so you use the is not. Are you guys taking discrete math? Is anybody taking discrete math right now or has taken it? So the next part is logic tables, which should make a lot of sense. Have you covered logic tables in your discrete math class? Truth tables, yes. Yeah, so you should be right up there with these truth tables. We call them logic tables, but truth tables or logic tables, it's the same thing. And here we go. Oh, I called them truth tables. Sorry. All right, so truth tables. So when you're doing a truth table, and if it's not on your homework this week, it'll be on your homework next week. So we're going to assume we have variables here, and we're going to assume that they contain these Boolean values. So we have A, B, and C, and we're assuming that they all contain true, and we're going to act upon it, and then we're going to go true, true, false, true, false, true, and then so on all the way through the different options that we have. So over here we have parentheses and A and B in parentheses or C. Now, order of precedence comes true when you're doing comparisons with Boolean values, just like it does in math. So it's always going to be parentheses first. So you always compute what's in the parentheses first, and then you're going to work left to right. Okay. So what I do when I'm working through these truth tables, you can choose what works best for you, but I just do that. So I've got A and B or C. So I just come over here. A is true, so wherever I have my A in, I substitute in that value. Then I take B's value and substitute in C's value. So here I have A and B or C, so that becomes true and true or true. Then I go back and equate my parentheses, so my parentheses true and true. Both sides are true, so that means it equates to true, so I end up with a true value. So I end up with true or true, and if either side is true, the whole thing is true, so the result of this is true. Okay. Here we have true, true, false. So again, I'm going to go true and true or false. Just fill in my values right here and then equate my parentheses, which is still true or false. And in an or situation, if either side is true, the whole thing is true, and I end up with true here. And then I did the same thing down here, but in this case, B is false, so true and false or true. So this equates to false or true, and it still comes out true because if either side is true, the whole thing is true. Okay. And I think I just worked through the different truth tables here. So you can see just working through them in their different components. All right. So if you guys, for those of you who are currently taking discrete math, this should be something that you're fairly similar to. For the rest of you, just really, just plug it in, just like I did here, false, true, true, false, and true, or true, matching up the variable. And then just ask yourself, am I in parentheses? Let's work on those first. And then is this an and? Both sides have to be true. Is this an or? Either side has to be true. And just kind of work your way through. It's really much easier if you just do it, switch in one thing at a time like this, as opposed to trying to jump from, visually going, okay, I got it, boom, it's this. You're likely to miss something or forget something somewhere. So if you physically write it out, it's much easier to get to the result that you need to achieve. Okay, a Boolean variable as a condition. So you can define a Boolean variable to contain a value of true or false, all right? If you're using that in an if statement, you don't need to do the variable equal true or the variable equal false because it already contains a value of true or false, right? So if we have this Boolean variable temp right here, Boolean temp equals true. We've set it to a value of true. So temp contains true. So we could definitely say if temp equal true, and that works, but WebCat is going to deduct points for you because it's redundant. We already know temp is true. So instead of saying if temp equal true, just say if temp. So if my temp has a value of true, then execute. And if it doesn't, then don't execute, right? So we don't need to say if it's a Boolean variable that we're doing comparison to, you don't need to check is it true or is it false. You just say if variable. And if it already has a value of true, you're good to go. And if it doesn't, then you aren't. All right, so like it is not in one of the labs, probably lab 3, WebCat, you'll have something like this. Yes, And that's perfect, except for you're going to have to put an extra set of parentheses in there. So it would have to be if not, and you could just say if not temp, just like that. Because since this is Boolean, you can put it there, or you would have to put an extra set of parentheses like this. So your condition, your if condition, is always contained entirely in parentheses. All right, and that brought us to the end. So any questions on the stuff that we went over tonight? Or the upcoming exam? All right, Dylan, I'll spend a minute or two going back over truth tables with you. So I do want you guys to know Lab 2 is available out on Piazza. I went over it during the Q&A session this week in the Week 5 Q&A, which that recording has been uploaded. So you, I'm pretty sure I uploaded. I will double check that, but I'm pretty sure I uploaded that recording. If not, it will be uploaded by the time we get done here. Oh, excellent. There you go. So Lab 2 is very different from Lab 1 in the sense that we have not introduced any errors in Lab 2. So if there are errors, it's something you're introducing, all right? Not something that we're introducing. But the Week 5 Q&A session, I'm pretty sure I already posted that out there on Piazza. So, and in the course itself. But like I said, I'll double check that just to make sure. But you want to start working on Lab 2. You've got, well, when is Lab 2 due? All right. The 20th. So that is 6 days away, right? So a week from Wednesday, it's actually due in the middle of next week. You know, so you got a short amount of time to work on this particular lab. So it's different in the Lab 1 in that you're going to do the majority of the coding, right? So you're doing the coding. There's no errors introduced. You're writing the test cases. You'll want to download it and take a look at that recording for the Week 5 Q&A to kind of get a walkthrough of Lab 2. Okay, so I'm going to spend, oh, so you've got, is that the Rev Tutor or is that THET Rev Tutor? T-Rev Tutor? Okay. So they talk about truth tables on that? Oh, here you go, discrete math. Video tutoring done right. I'm not sure if you can search for. So, oh, and put a link out there so you guys can check that out. But, yeah, well, yeah. I think the purpose is just practice to help you understand what happens. So it's really just a practice to get you practicing the ands and the ors with the trues and the falses, because you're going to write some pretty complicated if then else statements, maybe not in this week, but you will as the course progresses. And so the whole purpose of a truth table is to just help you understand how the ands work, how the ors work, and specifically how they work in combination with each other. And maybe just to torment students just a little bit as well. It is a lot of search type things as well, Google searching and stuff. So, you know, search algorithms would use, I mean, you don't specifically, it's not like we ever specifically think out truth tables, but you do have to think in terms of, all right, if I have this and I have this, all right, I need to enclose, you know, it's kind of like it just gets you thinking in terms of, all right, anding stuff together, oring stuff together. What's going to happen if I put this in there? Do I need my parentheses? Do I not need my parentheses? That sort of thing. So I can't say that I really ever think in terms of truth tables now when I code, but I did have to write a statement. I was trying to think of what one of my statements were today, where I needed, it was, I think it was a query actually, where I was trying to do some statistical analysis of our different ways that appointments are scheduled. So in our health center, you can schedule an appointment online over our health portal. You can call on the phone. You can walk in. You could actually walk into a kiosk without physically talking to a person. And so I needed to come up with things, and I needed to say, you know, if you're a nurse or an appointments associate and you don't have a triage record, then it was over the phone. So I had that, or if you're a nurse or an appointments associate. So I had to put those in parentheses because that situation needed to be true. And you don't have a triage record. So you had to have a triage record, and you had to either be a nurse or an appointment associate to qualify for this one type of scheduling. So it's not that you necessarily use the truth tables in what you're coding, but you need to understand how the ands and the ors combine together to accomplish what you need to accomplish in your program. And so it's just good practice to help you gain an understanding of the ands and the ors and how they work together. Does that help any? Okay, and the good news is we're only going to have one homework assignment on truth tables, and I can't remember if it's homework 5 or homework 6, but when we're done with that, at least as far as COMP-111 is concerned, you will be done with truth tables. I cannot speak for discrete math, however. No, 121 will not have truth tables. But you will have a bunch of if statements that you're going to need to write. They just aren't going to be truth tables. All right, I've run you guys over, so if you don't have any if you have more questions, I'm more than willing to stick around and answer them. But if you don't have questions, we can go ahead and call it a night. And for those of you who need to leave, feel free to go ahead and leave. All right. Have a great evening, everyone. I am running, do you mean because my screen changed colors? Oh no, it's, I don't know, whatever Windows put up there. I do run a program called Flux so that my computer automatically adjusts at sunset and sunrise to have kind of a red glow as opposed to the blue light. Because, you know, they'll say that the blue light impact, you know, disturbs your sleep patterns and things. And so last year I was having some insomnia issues. I don't have those anymore, which I'm very grateful for. But so I adjusted, since I'm on these chats a little bit later at night, I installed a Flux program. So my computer automatically switches to a red light when the sun is supposed to be down, and then goes to a blue light when the sun is up. So, yep. Yeah, there's some amazing things out there. All right, well, everybody have a great night, and post to Piazza your questions. You're certainly welcome to email me, but remember, you get extra credit for posting things to Piazza, and, you know, you'll get answers both ways, but one will get you a potential of greater extra credit than the other. So, All right. Have a great weekend, everyone, and we will talk to you next week.